good morning, good afternoon, and good evening to all the participants worldwide who have joined us for today's webinar. My name is Parul, and on behalf of ISGF and Hitachi, I welcome you all for the webinar on asset management, shifting from periodic to proactive and predictive maintenance. So in today's webinar, we'll be exploring how asset management is evolving, moving beyond traditional time-based maintenance to more proactive and predictive approaches. With the help of AI and machine learning in asset performance management, we can now better monitor asset health and plan maintenance based on real-time data, improving efficiency and reducing downtime. We'll also understand about the key areas like condition monitoring, aligning with ISO 55000 standards, and much more. Before we jump into the webinar, I request all the participants to please keep your audio on mute. Please do not unmute or turn on your videos during the presentation. And you may send any messages or questions, suggestions, comments via the chat box only. We will be compiling them and present them in the end of the presentation. This is a glimpse of today's webinar. We'll be having a welcome and keynote address by Mr. Reji Pillai, the theme presentation on asset management by Mr. SR Vijayan, followed by the Q&A session and vote of thanks by Mr. Akilur Rahman. Now I would like to invite Mr. Reji Kumar Pillai for the welcome and keynote address. A brief introduction about Mr. Pillai is Mr. Reji is the President of India Smart Grid Forum since 2011 and Chairman of Global Smart Energy Federation since 2016 with nearly 4 decades of experience in the electricity sector. Sir is leading advocate for leveraging technology to transform electric grids.
Thank you. A warm welcome to all the participants. I can see 56 of them now. I believe more than 150 people have registered for the program. We expect more people to join as we start. It's a very, very important topic on which Mr. Vijayan, expert from Hitachi Energy, will be presenting on the principles and practices of the next generation of asset performance management, leveraging artificial intelligence and machine learning tools. So Hitachi also is a valued member of India's Smart Grid Forum right from beginning. And as many of you may know, Hitachi is completing 75 years in India. So they've been here right from the freedom, in India's freedom days. So many areas Hitachi is involved, but the big grid management part, which Hitachi acquired from ABB, the power grid division, which do substations, high voltage transmission equipment, and HVDC, etc., are part of this division now with Hitachi. So we are honored to be part of several initiatives with the Hitachi, and this webinar which we are going to do today will be recorded and will be available on the YouTube channel of ISGF, which will be uploaded in a day or two. So coming to the main theme, as you know, artificial intelligence tools in last 5 to 7 years have several use cases, and which are in power sector also. Asset performance management is one of them, and data which we had in analog form in files, as all now in utilities, has become digital data, reliable digital data, which we have are a source where AI tools can be leveraged to make more sense out of this. And we also recently, as part of another grant program, we had done a very interesting study using drones. So 22 kV lines, one in outside of Bombay, which is Thane area, a 22 kV line, and also a rural line outside of Pune city. So 22 kV lines in Maharashtra, we have flown the drones and captured the images of the 22 kV line and analyzed using AI tools, and the revelations which came from that are very very interesting, very interesting, which the traditional method of inspection and the traditional method of analyzing, we would never been able to have those kinds of insights. And the tools have become now so uh, matured that even it can predict when a tree is expected to grow to a extent. A tree branch is expected to come nearer to the line with a 50 meters per second wind or 100 meter per second. It can predict to that extent. Yeah, if there is a wind of 100 meter per second, it can, this branch can touch in such and such places. So even for the vegetation management, which is one of the very important component of the total transmission line maintenance and management, are possible with these tools. Similarly, when you take images, the images from the substation, uh, the you all this drone based and other inspection tools which we have today have the thermal cameras also, so it can actually indicate whether a line is overloaded or a equipment is overloaded or not from the thermal data. So otherwise, a typical transmission distribution transformer which is on the street, if it is overloaded or even one phase of it is overloaded, we get to see only when it is burnt. Otherwise, from the naked eye, we have no visibility. But all these new practices are helping us to uh, graduate to the level of predictive maintenance. Even before an event occurs, we know it is likely to occur. We can take preventive action. So that will help in uh, the total O&M cost, in reducing the total O&M cost of the utilities. And Vijayan will be talking more in detail about the practices, the new tools, the practices, and also how it is aligning with the ISO 55,000 standards. So without taking much of time, I will hand over to Vijayan to start the presentation. Over to you, Vijayan.
So
Yep,
before
thank
we
you.
start the presentation, I would just like to give a brief introduction about Mr. Vijay. So for the theme presentation, the presenter is Mr. SR Vijayan, Principal Technical Consultant with Hitachi Energy India, leading digitalization and cybersecurity in grid automation. He has a background in electronics and communication and MBA in IT and marketing, has over 29 years of experience, including 24 years at Hitachi, and has the expertise in SCADA, EMS, DMS, smart grid, and cybersecurity solutions. And he's also an active member in Industry 4. He also serves as a vice chair of the ISGF working group on grid modernization and smart city. So with that, we'll start with our presentation. Over to you, Vijay.
Yeah, thank you. I'll share my screen and please let me know if it's visible. Is it visible?
Anita.
Vision, your screen is still not visible.
Yeah, I'm sharing it, but
So if you're not able to share your screen, maybe we can try from our end.
Yeah, okay. We'll try to stop the video and see.
So please give us a moment. We're just uploading the PPT.
Sorry about the glitch. We'll in 1 or 2 minutes we'll be up.
So we can see your screen. Stop sharing.
Is the presentation visible?
Yes, sir. It was just a few seconds back, but now we can see your screen, the real time. If you can just shift to the presentation, we'll be able to see.
Another way, you can just mail it to Parul and we will, or Ashma, and we will project it from here.
Yeah, I already mailed it.
Ashima, check whether you received it. Please project. Okay.
Is it okay now?
We are just seeing. Some perhaps it's a heavy file, so it's taking time. Yeah, we can see it now. You can go full screen.
Yeah, so now it's in the presentation mode.
Yeah, thank you. Sorry to everybody.
Yeah, sorry from my side as well. There's some maybe bandwidth issue. So yeah, good evening, and now we are all set to start. And I thank ISGF for providing this platform to present the solution regarding the asset management, which is very critical in today's scenario, especially when we talk about the reliability and availability of the systems. And as the topic says, why shifting the gear is basically, when you're driving a journey from routine, periodic kind of activity to a more transformed process. So it's not like changing it overnight. So it's a phase-wise approach, and the implementation plan has to be in synchronization with the process which is already in place, so that it is not overruling the existing SOPs and philosophies. So is shifting the gear is like going from one phase to the next phase, so that when you climb the ladder of your journey towards digitalization, in which asset management is one aspect of it, so you reach to your goal of ultimate ambition. So with that introduction, we have the agenda today for the digitalization introduction. Just to set the context, there are a couple of slides to just give the different technologies on the digitalization side, and then how few of these technologies are used in asset performance management, which drives us to get the asset visibility and also have the proactive and predictive maintenance possible as part of our maintenance strategy. And then we have summary followed by Q&A. So normally when we talk about digitalization, there are always two terminologies, digitization and digitalization, which sometimes are introduced. basically to give the idea of digitization, it is conversion of data in a very physical format to a digital format. Like for example, you must have seen the earlier photographs which were printed on a paper or sheet is now available on a digital format in the pen drives or and on the disk. Similarly, when we talk about the systems which are on the distribution, transmission, or on the process plant side, so it is again the drawings and all the process flow of the system.
Vijayan sir, I'm sorry to interrupt in between, but your slides are not moving, sir.
Is it?
Yes, and if you can just make it in full screen mode also, the slideshow
Yeah,
mode.
it's already in slideshow.
Okay, but slides are not moving, so if you can just
Okay. Maybe it's taking time because of the bandwidth. So can you help me with the navigation menu?
Sir, maybe you can just go ahead and continue with the presentation. Meanwhile, we are just reducing the size of the presentation and uploading it from our side.
Okay. Yeah. So that's on the digitization part. So where basically the information or the data which is available in the physical format is converted into the digitized so that they can be used more flexibly. Whereas when we say digitalization, it is the use of that information into changing the business model and the process. So we use those digitized data and then plan our strategies and the business operations in a way that it is allowing us to it's about the transformation. When we say it is not only something on the software side, but also it is the entire gamut or the value chain of the infrastructure. So we call it as field to the boardroom. So starting from the equipment, especially as the topic is today on the asset management. So the assets are on the the field side. So starting from there, how do we collect the data, transform that data into information, useful information, and use that into predictive analysis using the algorithms, which we'll see in the coming slides, in making the strategies towards the transforming the process and the methodologies that we use in driving the overall business goals. And also it helps in by changing the skill set of the the workflow which is happening. So it may not be completely like the way that we are doing, but then there are certain skill set that will be required to interpret and use those data in the meaningful way. So I'm now on the slide on digital technologies. So is that visible?
Vijayan sir, we have shared our screen,
Okay.
so maybe you can guide us.
Okay, sure.
This is the slide, right?
Yeah.
Okay.
Yeah, so these are the various technologies which we talk about in the digitalization journey or transformation. Not It's not that all technologies are used in a single platform as a solution. So depending on the requirement and the need and what exactly we want to transform in our whole process is like a pick and choose kind of the shelf we have. So the virtual and the augmented reality is about having the virtual visualization of the assets or the systems that we may want to serve. It can be like a remote service, or it can be like a remote factory operations and those kind of things. Machine learning and AI ML, which we popularly call it, it's about having the data collected into the system with those systems coming from the field, the sensors, or it can be offline data. And also, how do we use those computing algorithms in driving the business goal and the application that we are actually looking for finding the solution. And also there are different types of solutions which can be either on-prem or cloud-based. So there are a lot of computations, as we talked about, the algorithms which are driving the predictive models especially. So they have a lot of computations inside which gets into the calculations. So there is again the cloud computing technologies are used, and also the connectivity with respect to when we want the data to be coming online. So the connectivity from the field towards the central data lake is very critical. So here is, though it's not a real-time system that we are talking about in this uh, analytics, but then it's about having the data which is much more useful in driving the analytics and also deriving the required say the KPIs and the dashboards. And cybersecurity, of course, today is one of the important aspect of whatever we do. Like especially in the automation side, be it the conventional automation like the SCADA systems, or an advanced analytical and digital systems like asset management. So this cybersecurity and the layered approach is very critical in that. So when we talk about the asset management, it's about the machine learning and the analytics of the big data, which will be mostly used, and of course the connectivity aspects when we want to take the online data from the sensors. Next slide, please. Yeah. So now, with that background on the technologies which are available and which which are being leveraged into different solutions. So now we look at the asset performance management, which is, as I told, basically applies towards the optimization and reliability and availability of the system as a whole. When we talk about availability and reliability, is mostly on the process side or on the network side, where we try to talk about the faults or the production systems which are there. But it's also important that for the asset managers and the asset owners perspective, the availability of the asset and also the capability to predict a failure and convert a breakdown maintenance to a preventive maintenance is very critical in attributing towards this reliability and availability of the system. So we will see in the coming slides how exactly we use this technology in arriving that solution. Next slide, please. So why do we need asset management? Why we are talking about such a maybe high-end technology in a typical process, or the operations that we are and we were doing over more decades. So what is the actual need of it? So one is the combination and the aging infrastructure. And when we say aging infrastructure of the assets, it is not just the age which has been lying in the network, but also the operational conditions, because it could be possible that some of the assets which are very old may not be in operation because of the operational needs, but then some of the assets which are maybe quite new, they are part of the very critical and very high-end operational requirements. So the combination of the age as well as the operational condition of the aging infrastructure, that is one of the factor, because that visibility, if it is not available, then it is not possible to really have a maintenance philosophy which is driving based on the asset needs rather than a routine maintenance check. And then the workforce combination. So we see that the organizations are recruiting new people. There are experienced people, the domain expertise, especially when we talk about equipment and assets. So it's the domain expertise that is very important here, because when equipment behaves in a certain way, it is necessary to identify where exactly is the problem and how it can be solved. Right? What we say is, it's not. We should know where to hit the hammer, right? So that's the experience that the organization brings with the experienced professional. But also when we recruit new, people into the workforce combination, how through the process we can have a seamless, working and a workflow process which can be there. And of course, I already stressed about the high availability, reliability, and the efficiency. So it's not just the process or the network that we are operating, but also it is these asset components which are making those network to work as required. And prioritizing and replacement. There's always a debate or kind of a dilemma whether we do a replacement or we do the maintenance and then just stretch the breakdown. So you need tools where you can really take a decision which can drive into the into your perspective of how it what kind of priorities you can set and when you can replace, what are the budget estimates that needs to be done and things like that. So this is always a dilemma within the maintenance people, like when to replace or when to do a repair maintenance. And when we see this data, so all the sensors which are collecting the data from the field, or it can be offline data which already you must be doing from the inspection and the factory tests. So converting this data into information. So that is very important, because just the data as such is not sufficient for driving those strategic decisions. While the alarming and the attention can be there, but then to drive a strategic process transformation, it's important to convert this data into information. And then the 55,000 is the standard which is for benchmarking the best practices in maintenance process. So as an user organization, you all must be aiming, like we normally aim for ISO 9000, then in cybersecurity we aim for 62443 and all those kind of different standards. So towards maintenance activity as well, it is important to benchmark, to optimize, and have the workflows in flow with respect to the benchmark standards. And then how we will also see is not only the process optimization and all the network availability, reliability, but how it also helps your O&M budgets and the capital expenses optimization. Next slide, please. Yeah, so this slide shows you the cycle of the asset management. So it starts from the collection of data. So it can be different sources of data. It can be offline data, online data from the sensors, or it can be pre-existing systems which can be interfaced. So basically the data from different sources which are collected, which is shown.
नहीं बताना तब तो हम दो हमारे दो के चक्कर में पहले होता था 5-7 आदमी.
So once the data is collected, so as I was mentioning, it needs to be converted into information. So that is where this intelligent, the asset models or the prediction models are residing in the asset management tools, where the different types of asset models like transformer model or turbine models, circuit breaker models, or your motor models. So there are different types of assets and different algorithm models which are running into this asset management tool, which then derive useful data and predicts the threshold values, the limit, the ranges within which the assets have to operate, and then based on the overall asset behavior. So it's not just the parameter alarm which typically we see in SCADA systems or remote monitoring systems. It is combining this data and the violations into a useful information which which will be actually used by the maintenance engineers or the technicians when they go to the field, and then they can really approach the problem in a very specific way rather than in a subjective way. And once this is done, of course, we also need to act on that and then track it. So say, for example, if there is a recommended action coming out from this asset performance management, then how do we define the maintenance schedule, maintenance planning, and then trigger the job cards and have the tracking from the field technicians. So this is the life cycle or the cycle which a typical asset management follows. Next slide, please. So when we say data collection and the algorithms or the AML models which are running into that, and what drives the asset performance management as a holistic solution is the different building blocks, where it starts from the data source, as again I mentioned, the IT sources or the OT sources, which means that the offline data, which are typically in a digitized way, and then the OT sources are coming from the sensors. And then there is a possibility, as we see in the middle, that it can take this data to the data services, where we integrate this data into a single layer, or it can also have edge analytics. So if you want to have a small scale edge analytics within a local area, so that's the possibility of doing that, building a small algorithm model within the edge device. And further, it also, so it not only does analytics locally, but also it can send those output to the integration layer or the data service layer. And then the solution, what we are talking about on the right side, where the asset performance management and the other types of solution, Mr. Reji also spoke about the image analytics and the video insights. So there are different, the digital insights and digital technologies which can be applied. So the building blocks start from your data source. So it's basically seeing the cycle, the data flow cycle, what we saw in the earlier slide with respect to the block and how it is getting connected, and how we can have different approaches. I mean, again, what we implement and how we approach to the overall solution purely depends on the requirement, but it's important to get a start. So that is why it's shifting the gear. So if you're in a neutral gear, your vehicle will not move. So you need to shift from neutral to the first gear and then go to the fourth gear or the fifth gear. So that is where it's important that it's important to start the journey and then drive all the way where we want to go. Next slide, please. So this slide gives an understanding like how exactly we integrate. So this is talking about the left layer where we saw the data sources, and the middle layer the data services, and the APM which is there on the bottom. So it is the solution side. So if you typically if you can think about your process area or your switch gear area or your the working layer of the equipments. So there are different types of equipments. It's just an example what is shown here, and these equipments are driven by different types of sensors depending on their condition monitoring requirements, and they are communicable. So nowadays you get sensors which are communicable. You don't need to hardware them. So there are standards like 61850 or Modbus, which typically used for this sensor communication, and you can collect it into your central system. So that is the data lake or the data service. So now if you correlate this slide with the previous slide, so what you're seeing on the left side, in the process, that is the data sources, and the OT is your data lake or the data service layer, where the data is collected and stored centrally in the historian system, and then that is interfaced with the APM where all the algorithms are being executed. So while the online data is coming from the field, it's also possible to parallelly integrate the offline data. So it's like, for example, if an asset is having 20, 40 parameters, so it need not be that you need to go and sensorize each and every aspect of the asset. So you can do a partial sensorization and also have partial offline data based on your inspection that you are carrying out, and then feed that into the APM tool, which can combine this information into the asset models, where it combines the online as well as the offline data in a very seamless way, and produces the same result or near to the same result with respect to the online data. And again, when we say online, it is to be understood that it is not real time. So we are not talking about milliseconds and seconds of data. It's more on the analytical side. So the periodicity should be optimized so that we really use the best side of the available data as well as on the say bandwidth and the processing capabilities. So I would not say it's a trade-off, but then it's more thinking of using the data more in optimized way rather than getting every second data into the system for. Again, it depends on what kind of tools we use, but then when we talk about asset management, it is more on the analytical side. And then you on the left side, you see some of the deployment methodologies. So it can be cloud-based or on-prem. When we say cloud-based, they are hosted. They are hosted on the on the cloud, as it says, and it works on software as a service model. So basically, you don't need to have any physical hardware in your premise, and you just subscribe to the tool license, and then you get all your upgrades and updates and everything automatically on your laptop or mobile devices. And when the other deployment method is the on-prem, which is installed on a physical server in your premise, and then you can use it as a normal normal system what you do. What is normally seen, or what is experienced, is that the cloud-based system is easier for deployment because you don't really need to wait for procurement of hardware and things like that. So once you start the day of your journey, so within a few weeks you are up running with the system. And then the scalability and maintenance. So again, when we talk about scalability, it can be either horizontal scalability, like increasing your asset types, or the vertical scalability, like you want to add more number of assets of the same types. So either way, the cloud infrastructure gives you the flexibility of expansion. Whereas when you're talking about an on-prem solution, so you have to have your design in the initial stage itself, rather than you can go for an upgrade when you want to expand the system. And the maintenance, again, one visible thing is that when you're on the cloud, you don't have anything to maintain. And also it's about the security, because we touched about the security aspect as well, which is very critical. So getting the updates, the patches, and the security updates is very critical. So when you are on the cloud, it is automatically deployed and available, whereas when it is on-prem in a physical server, so you need a mechanism where it can be deployed. So either manual deployment, or it has to be on a central system where it can be deployed. And also you need to get those patches physically into your system rather than making it automatically available. So these are the different possibilities and the few benefits with respect to the cloud-based. Next slide, please. So when we say asset management, or the asset condition or the performance management, so there are three aspects which can be thought of. So first and foremost is the health, the knowing the health of the asset. So without knowing the health, we cannot think of making a reliable approach, or doing any optimization or doing a maintenance planning. So the asset health is the first and the foremost. And then how we drive those the visibility, which is getting into the system, into reliability and the optimization. We will see in the coming slide what exactly we talk about reliability and the optimization side. Next slide, please. Next slide. Yeah, so the asset condition is about getting that visibility, as I told. So that is the first and foremost, to get the visibility of the asset, and also how we monitor the condition and the risk matrix. Based on that, where we can have the priority of the maintenance, and also maximize the availability based on the health indicators, which are possible as an output to the APM information. And also we can, as I was telling, once you have the visibility of the asset, so you don't allow the asset to break down. So you convert the breakdown into a preventive maintenance by having the probability of failure analysis as part of the model. Yeah, next slide, please. Yeah, so when we talk about the reliability, so once you have the condition of the asset, and then what is the risk profiles which are there. So it is not just the condition or the parameters of the asset, but also there is a risk matrix which is based on the condition of the asset and also importance of the asset. So where do where you map the asset with respect to your fleet of assets which may be there, and also the different risk profiles based on the asset category, and also, as I told, the importance of the asset. Because if you have the same type of asset, each of them may not be of the same criticality or importance. So depending on their the placement of the on the processor network, so it depends on on how they are exactly important and critical, based on which the risk profiles are calculated. And also the different maintenance strategies, and comparing an asset with respect to the family of fleet of the same asset types. So this becomes that is why the reliability centered maintenance, when we talk about it, becoming critical. So when you have family of assets of the same type, how do you prioritize your maintenance within that system? Next slide, please. Yeah. And then the optimize. So as I was talking in the beginning of the asset management slide, where we also talk about the optimizing the capital cost, and also the O&M budget, so that you can have the analytics in the asset management tool, where the replacement with respect to the capital expenditure, and also the risk of the asset. So you can have different probabilities, and the calculation analytics which can be done with respect to the asset condition, and also the asset categories, and also the overall life cycle of the asset. Because when you are buying an asset, so it has its own life cycle. So with respect to that, in comparison, so where exactly the replacement score is standing, and also the maintenance versus repair. So you can have those analytics done, so that you can prioritize your actions uh, based on the asset condition. And also, if there are any constraints with respect to either your budget, or your risk of the asset with respect to the availability. So sometimes it's possible that you may have an asset which is in a failing condition, but then you still have an alternate way of feeding that. So you want to reduce, or you want to defer your capital expenditure. So all these kind of analytics are possible based on the health condition which is coming in, and also the algorithm models which are built in with respect to the asset models. And these asset models, when I say, I'm not taking the specific name here because it's applicable to different types of assets. It can be static assets like, your transformer, circuit breaker, capacitor banks, which we typically see, or it can be rotating assets like turbines, gearbox, motors. So it can be, different types of assets. And that's where we say the models which are running, the AML model algorithms which are running is very critical, so that the independent data, or the raw data which is coming into the system is converted into the behavior of the asset. Knowing the behavior of the asset and the specifications and these different standards which may be applicable. So we will see as an example in the coming slide, when we say different standards, how it is applicable with respect to the asset maintenance. Next slide, please. So what we spoke about or saw till now is about monitoring and the diagnostics. So when we say monitoring, the visibility of the asset, and the diagnostics is what is the problem, where the problem is, what is the condition of the asset, what is the risk matrix score, and all this. So with that, whether we will be able to do a predictive maintenance, no. So you need to have a prognostics capabilities, and then where you can do a what if analysis, and you can also see the expected time of failure, so that you can anticipate the failure and convert it into your preventive maintenance. As I told, converting instead of waiting for the breakdown, you take action so that you don't allow the breakdown, but then you have a preventive maintenance check, so that you have the asset working for you and making the availability more critical conditions. And also the what type of malfunction or the failure, because the behavior as asset maybe can be into different aspects and different conditions. So there can be, when we say rotating assets, so it can be mechanical, and also it can be electrical faults. So there can be different characteristics of the behavior of the asset, which is driving into different asset failures. So that's also one of the key thing to know what maintenance action needs to be taken, and what kind of recommended actions are coming out with respect to the maintenance strategy. Next slide, please. So this slide shows an example, like I was talking about the what if analysis. So on the left side, you can see a condition which is an asset running in full load, and in the bottom you can see a lot of parameters, and you see green and yellows and red boxes, which means that there are many parameters which are getting into a warning zone or a high risk zone, means yellow and the red boxes. Whereas if you are able to reduce the load from full load 100% to 95% load, so this is simulation condition. So it is not you are actually reducing it in the field, but then when you simulate and see by reducing the load with 95%, you can see most of those yellow and red boxes are changing to green, which means that you are allowing the asset to perform in a normal way by reducing this load. And this also brings in the synergy between the asset maintainers or the owners with respect to the operators, system operations. So that, if there is a way of reducing the load, and then you can transfer this a load to another process or process lines. So it is possible that you still have the operations on, and then you still have the asset performing to the satisfactory levels by doing the simulation and actually executing, planning and execution in your in your operations. So this kind of simulations is what we talk about, prognostics. You can see how the behavior is going to change, and what is the timeline in which a particular asset is going to deteriorate, or what is the curve. You can also see a curve, which you don't see here. It's more of the boxes, but then you can see the curves where you can identify the behavior sluggishness of the asset. So because when an asset fails, it is not a sudden failure. There is a deterioration in the behavior, and the curve that you will be seeing as a simulation model is on the behavior pattern itself. Next slide, please. So now once we have seen the different methods, and we have seen the different terminologies what I've been using, like the risk assessment, the maintenance priority, the replacement score, and all this. So we will take an example of an asset and correlate with respect to what we were seeing till now. So this is an example of a transformer. And as you can see, the different data which is there. So you can see on all the three sides, you have different data sources. So it is always possible when you're doing an automation, conventional automation or a first level automation, you have a system where you are collecting some data into a central system. And then you also have certain systems which are in the offline. So you can see on the left side, which is typically a SCADA. I think most of you can correlate to this terminology SCADA, which is supervisory control and data acquisition system. where it's basically connecting to the remote plants or remote substations or remote area, and then it collects the different types of data. And the offline data, as I mentioned, is your inspection reports. It can be your field report. It can be your commissioning report, FAT reports. So all this kind of which you have in some way available, digitized way, or if it is not digitized, then we need to digitize. So that is where the digitization and the digitalization work, work in correlation to each other. And then on top of these two, which is like readily available, we add online sensors. As you can see on the top, we add online sensors to bring more information. And on the right side, you see the analytical tool, the asset management tool, which is running the models, and then with the use of this different data, it is giving the recommended action. So basically, it means that the equipment on your hand. So you don't have to go to the field to really see the behavior. You run your models here, and it's available on your hand, and then you just take the action with respect to what are the recommended actions. And in fact, you will also get the time period by which you need to take an action. So there can be certain situations or conditions where you may have to take an immediate action, or there can be a situation where you still have few days or months to take an action, so that you can plan your maintenance accordingly. So that's where the maintenance priority comes into picture. So this typically we can also say it as we hear OT IT convergence in respect to software application, but here we can also see the OT IT convergence with respect to the equipment and the software tool which we are using to bring that equipment onto our boardrooms. Next slide, please. So this is what I was mentioning about converting the data into information. So you can see it is not just the alarms or the messages or the trend curves. So you can see the detailed recommended action which is being displayed here for again an example asset, and it shows the different the parameters which are contributing the categories. The blue graphs that you're showing in different colors. And then it also tells you, as I was mentioning, when you have to take an action. So like, for example, the highlighted one in this slide, running in the background, which is taking the asset specification. Like, for example, if you take your transformer in this case, so it has different parameters and different standards which are applicable on different analytical methodologies. So it takes all those into consideration and then provides this information so that you can plan your maintenance. Next slide, please. So basically, this I'm not getting into more deeper of the different kind of visualization that you can get, but more how you can convert your raw data into the information, detailed information, and how you can get a more detailed recommended action for planning your maintenance. Yeah, next slide, please. Hello.
So we have just moved the slides. Maybe there is a lag for a few seconds. We are now on the Lumada APM asset summary view.
Okay.
Is it visible, sir?
Yeah. Okay. Thanks. So as you can see, I was in this slide you can see the different asset, and you can also see the marked maintenance score and the replacement score. And the replacement score takes different factors like the financial, the age, or the importance of the asset. So and it's not it can be like customized depending on your factors or the weightages that is required, and based on that the replacement score is calculated, so thereby giving you the information on hand that is required for planning your budgets. And also you can compare with respect to the different asset types, the category of the assets, and also the geographical area of the assets, and plan your replacement based on the so here you can see, like the replacement rank is 2 out of x number of assets. So if sometimes it may not be possible to have a decision taken, because you have a similar kind of behavior on two different assets, but then how do you prioritize your maintenance or the replacement? So this is how you can compare, and then you can plan your replacement and maintenance accordingly. So this is again a calculation which is running at the background of the algorithm, where it calculates based on the weightages and the factors which are provided, and also with respect to the with the parameters which is coming into the system. Yeah, next slide, please. Yeah. So in summary, if you see what is asset management, it's about the asset visibility. First of all, bringing the visibility into the the common visualization tools, and having the history of the assets, and also knowing the risk assessment, the scoring of the different asset types in the family or fleet of the assets, and also knowing the issues of where exactly the problem is, how it has been generated, and what recommended actions have to be taken. And also it has a comparison with respect to the standards which are applicable for different asset types, and also bringing the comparison with respect to the different assets. Like in this you can see that there are about 10 assets of the same family, but then they are into different risk zones. So where you can plan and bring in the information of the critical assets into the main planning strategy. Next slide, please. So this is the mention, or the change of gear I was talking about, where you don't go from the today's periodic maintenance or use-based maintenance to directly a reliability-centered maintenance, but then you move towards condition-based predictive, because the machine learning and the analytics which are built, they have a maturing model based on the the inputs which is coming, and also the patterns which are getting developed over the period. So you start with the condition, and then it moves towards the predictive and prescriptive maintenance, and then towards the reliability centered, where we saw about the risk of failure, and the expected life and all this. And then financial optimization. So it is you can build in analytics once you have this reliability centered maintenance and the predictive actions. So you can have the analytics which can be developed to have your capital cost optimized, and also plan your inventories based on either deferring the purchase of inventory, or you can also have your maintenance schedule in place to align with your inventory plans. Next slide, please. So when we talk about the integrated asset management, so what we saw in detail is about collecting the data, analyzing the data with the models, and then we have the prescriptive information, and how do we act and track, right? So that we are not seeing. So basically what we do is integrate this asset performance module into the ERP systems, or into the maintenance planning systems, which can take the recommended action with the time periods, which is coming as an information from the APM, and uses that for maintenance planning and scheduling and creating job cards, and also assigning crews, so that the crew members are assigned based on the time schedule of the maintenance, and the crew also can have devices or applications in their mobile, so that they can feed in their actions on the observations. So two aspects of feeding the information or feedback is the corrective action that they have already taken based on the prescription, and also their observations, which could be different because the asset is running on a continuous basis. So also the observations which can be there fed into the system, which again gets into the offline data mode. So we saw about the online or offline data collection, so which gets into the system for the algorithms to run and have the new assessment, risk assessment, and condition monitoring enabled. Yeah, I think this was the last slide. Yeah.
Thank you so much.
That was from my side on the presentation part. So if there are any Q&A.
Yes, sir. We have some questions and we have compiled them in our presentation. So we'll be sharing the slides for that. Sir, I hope the questions are visible.
Yeah, it's visible. So the first question is, apart from 61815 modbus, which is generally classified as SCADA protocols, what other IoT protocols are used for? Yeah, again, when we talk about APM as a tool, so it's how do we collect the data from the different systems? So we saw the building blocks where there are the edge solutions, and also where there are the centralized solutions. So these protocols, what I was mentioning in the typical architecture, is where we collect the data using these protocols. And there are protocols like MQTT, which is typically an IoT protocol which is normally used. But again, it depends on what kind of connectivity we want to have, and how many sensors to be connected, and how it has to be overall layered in the architecture. Because if there are too many connection points, that will also be a problem for having the nodes enabled for those connections. So it has to be planned with respect to more overall architecture, layered architecture that we want to build. But then MQTT is another protocol which is used typically for IoT kind of sensor data acquisition. What is the native cloud deployment supported by APM platform? I mean, if you are asking about any specific cloud, so this is Lumada APM is cloud agnostic, so it's not on any specific cloud, but yeah, it's cloud agnostic, and it can be deployed on different platforms. How are you integrating third-party ERP into? So there are APIs which are running in the both sides, I would say. So the required parameters are configured, so there can be REST API, or some systems also have the ODBC connections. So it depends on what the ERP solution is on the other side, but there are different ways to do the integration parts. So API and ODBC are typically the ones that are used. Where these systems are installed and in operation. So there, okay. So these are installed globally in different, I would say, segments. So it is deployed in power utility side. It's also deployed in renewable side for wind turbine monitoring and gearbox monitoring. It's also used in the process plan. So there are different segments and different install bases for this kind of system. Again, the slide is not visible. Is it predicting the residual life of the asset based on the health and age of the asset? Yeah, so residual life, it does predict, but it's not just the health and the age of the assets. As it told, there are different weightage factors which are there, including the risk assessment, so and also the importance of the asset. So based on all these conditions, so it predicts the residual life. Can we create asset health register? Yeah, of course, it's possible. So are there any more questions?
So we have a question from Mr. Chaitanya Kumar, and he has asked us to predict asset failures, whether parameters are enough.
To predict the failure?
To predict asset failures, whether parameters are enough.
Weather parameters. No, I mean, yeah. See, we don't really talk about the weather parameters. It can be an additional information, of course. So because ultimately we see the asset behavior parameters, I would say. So because the weather is one aspect of it, which also makes the asset condition to behave in a certain way. So right. So based on the weather condition itself, the behavior may not be a good prediction. So it is more on the condition of the asset where we can predict the failures rather than the weather condition itself. So if that is a weather parameter that is mentioned in the question. And slide number 17, what is MTMP risk of failure? Okay, so the MTMP is a typical algorithm used for transformer analysis. Slide 17, I assume based on the question, it must be the transformer slide. So it is the MTMP algorithm for risk failure assessment, which is typically used for transformer.
So question number 1, 2, and 3 are also some new questions. So we'll take in reference.
Are there any indices of transformer health indication being calculated? Yeah, so if you mean like, for example, the WTI, OTI, the DGA gases, yeah, depending on these parameters, as we also saw in one of the slide where the analysis was done for the DGA, and then it was basically a rise in the temperature, which was the cause of it. So it is possible. That's where the conversion of the data to information, because otherwise it's not possible to just read the data and then take up the maintenance. So it is possible to suggest the maintenance activities based on the overall asset condition rather than a parameter. How are you ensuring cybersecurity APIs being used? So Again, it depends on what deployment we are talking about. If it is cloud-based, infrastructure, so I already mentioned that cybersecurity aspects and all those the the cybersecurity updates and all these things are automatically taken care, and the infrastructure, the cloud infrastructure is already having layered services which are available, and that will be utilized. And when we talk about on-prem deployment, so it just depends on the architecture that we implement. So typically, when you want to expose the API of say APM to the ERP system, so it can pass through a firewall as a simple example, or there can be other means. But yeah, both will have different types of approaches. When we talk about cybersecurity, the on-prem approach and the cloud approach will be different. How you come across any challenge integrating all? Yeah, so to answer this, I mean, okay, it will not be directly answering your question, but then when we do offline testing, okay, so there could be a lot of dependencies, including, say, the uh, quality of sample being collected, the environment in which it's being stored, and all those. Whereas when we implement solutions like this, so at least the handling part and also the sampling part and all these things are taken care. And it's not only the environment. When we say it's not just the environment in which it's stored, it's also how it is transported and all. So yeah, so there are what you call, there could be differences between offline and the tool based, but I would say that the tool based is much will be more accurate than the offline test. What are your views about mobile based asset management application? Yeah, yeah. So as I already mentioned, the equipment on your hand. So this typically what it does. So it brings the equipment which is in the field on your hand by doing those analytics and predictions. So the tool that we are seeing, the APM tool, so it can be on the tab or it can be on the mobile, so that you get the visibility. And also I spoke about the crew management, or the maintenance technician who goes to the field. So he carries the mobile devices and also can feed into the system is corrective actions and also the observations. So basically, yeah, it is it is possible. Other indices, so this we have already done. Ensuring what are the indices being suggested nameless? The fourth question I'm not able to understand.
Mr. A, can you please elaborate on this question, please? So maybe we can move ahead with the other questions. Meanwhile, Mr. A
Okay.
elaborates on this one. So we have another question by the same person. What about ensuring cybersecurity of clouds located outside the country?
A cloud outside?
Outside the country.
No, can you show the question? It was not audible clearly.
It's the
Yeah,
last.
okay. Yeah, okay. Located outside the country. Yeah, so what we typically do, as again I told, it is nowadays most of these data centers are available within the country. So this again depends on the specific case. As I told, it depends on the architecture that we want to deploy there. But most of these cloud services are available within the country. But yeah, if there is a specific case, then what we do is we work out the architecture layer in such a way that the infrastructure is still protected. Infrastructure and the data is also protected.
So thank you so much, sir. We had a very good discussion just now for the presentation also. We will now.
Thank you everyone for participating, and thank you once again to ISGF for providing this opportunity to make the presentation. Thank you.
Thank you so much. So before you leave, may I request everyone to kindly turn on your cameras. Dheeraj sir, maybe you can also, you have your camera on already. Vijayan sir and everyone, all the participants, so that we can have a very good group picture. Requesting everyone to please turn on. Just a few more seconds. Thank you everyone for the group picture. We will now be moving to the vote of thanks. And for that, we have Mr. Dheeraj Jain, Government and Institutional Relations, India, with Hitachi Energy. Just a very brief introduction about Sir, that he has over 17 years of experience in strategic planning and business development, and in driving revenue growth and managing operations. He has also a very strong experience in creating sales strategies, building distribution networks, and forming strategic partnerships. He has a strong track record in enhancing performance and navigating regulatory challenges. He is also known for high energy and excellent relationship skills. He has consistently achieved revenue and profitability goals while mentoring the teams. So without any further ado, would like to invite Mr. Dheeraj Jain on stage.
Thank you so much, Shima. Thank you. I hope I'm audible.
We can hear you, sir.
All right.
Yeah, you can.
Good evening, everyone. As we come close to this insightful webinar, it is my privilege to deliver this vote of thanks. So thank you, ISGF, for giving me this opportunity. First and foremost, I would like to extend my deepest gratitude to my colleague, Vijayan, for his excellent webinar and insightful topic that he has touched upon. I'm sure most of the participants would have reaped benefit out of this, and it's our endeavor to take any questions offline, if you have any, to answer. It would be our privilege to do that. I would also like to thank for your active engagement throughout the session. Your questions and contribution enriched the discussions and made the webinar even more successful. A very special thanks goes to, in particular, to Reji sir, Ashima, Reena, and entire ISGF team as our organizer, host, whose hard work has been behind the scenes has ensured that this webinar ran smoothly. So without your dedication, sir, and your team, this wouldn't have been possible. I would also like to thank everyone who played a role in bringing this webinar to life. Let's carry forward the knowledge we have gained today and apply it to our respective fields. Once again, I sincerely thank everyone for your time, valuable time, and your active participation. Have a great day. Thank you so much.